Hey everyone, today in this video I will be going over learning target 9, which relates to derivatives of a function, specifically derivatives of polynomials, exponentials, and trig functions. So let's just jump right into it. We're asked to compute three different derivatives, and I'm going to look at this first one now. And what I'm going to do is I'm going to rewrite this h of x function into terms of, well, as like with this term right here, for example, it's a cube root of x to the 8th. I'm going to write this in the form of x to the some power, or something power. Same with this one right here. I'll have x to the something power with the coefficient in front. That makes it a lot easier to use the power rule. Okay, so for the first term, we will have x, and then x is raised to the 8th power, and then you're taking the cube root of that, so 8/3 power, minus, we have a coefficient out front of 5/2, and then we have 1 over x cubed, and we can rewrite that as x to the -3 power, because the -3 power, write that on the side, x to the -3 is equal to 1 over x to the 3. And then e to the 4 will just be e to the 4 in terms of writing the function. But now I need to take a derivative. So notation-wise, I will have h prime of x. And now I need to do the power rule for the first term. This 8/3 will go in front, and then we'll subtract 1 from that exponent. So we'll have 8/3 x, and then 8/3 minus 1, I'll write this on the side, 8/3 minus 1 is equal to 8/3 minus 3/3. We need a common denominator to this subtraction, and then we get 5/3. So 5/3 power right there. And then for this next one, that -3 will come in front, and then we will subtract 1. And -3 coming in front, -3 times 5 over 2 is just equal to -15 over 2. But then this value is being subtracted right here, so we end up with a plus. Plus 15 over 2. And then x to the -3 minus 1 is -4. And what's the derivative of e to the 4? A lot of people were tripped up by this. It is 0. That's because the derivative, write this here, derivative of some constant equals 0. It's very important to remember. Sometimes just looking at the e to the something power, it makes it look like it's a function, but e to the 4 and e to the anything is not a function. It's simply just a value. So I'm going to erase that for now. All right, so this is our answer for the first one. Oh. All right, now g of the x, or g of x equals 4 cosine of x plus 7x to the 10th minus 12 e to the x. This is in a good form as it is right now to do the derivatives of trig functions, polynomials, and exponentials, so we can leave it. And now we'll have a g prime of x. Taking derivatives of sine and cosine, it's good to remember that d dx of sine x is cosine x, and d dx of cosine x is negative sine x. Just things to memorize. So we will have a -4 sine x. Now we'll do power rule for this next term, where that comes in front, and -1. So we will have plus 70x. 10 minus 1 is 9. And then derivative of e to the x is just e to the x, but we have a coefficient in front. So minus 12 e to the x. That's our answer. And then one more derivative. First term looks good in the current form. that I like it to be in for power rule. Second term is just trig, so that's fine. Third term though, 11 over the square root of x, I don't really love that, just looking at it. So I'm going to think about how I can rewrite that in terms of something that'd be easy to use the power rule for. So that 11 will be a good coefficient, and then we have 1 over the square root of x is equal to 1 over x to the 1/2 power. But getting it in a little bit better form, we'll have x to the negative 1/2. That's the best form for using the power rule. All right, now we can take a derivative. So the derivative of 6x, technically it has a power of 1 if we need some help with the power rule. So that goes in front, and then minus 1. 1 goes in front, times 6, that's just 6. X to the 1 minus 1 power is just x to the 0. And x to the 0 just equals 1. Anything to the 0 equals 1. So that'll just be 6. Then minus 4, derivative of sine is cosine. And then another power rule step that comes out in front. And we have a negative 1/2 times negative 11. So I end up with plus 11 over 2 x. And then negative 1/2 minus 1 is equal to negative 1/2 minus 2 over 2, which equals negative 3 over 2. So we'll have a negative 3, oh, that is like a 3, negative 3 halves power. And that is the derivative. So all of these, like as you can see, it's not a ton of actual computational work. My biggest suggestion, especially when it comes to the power rule, is just getting all of your x values into x to the something power, where n is just something. That's the easiest way to do power rule, because then that n can go in front, and you subtract 1. And then when it comes to trig, it's just memorizing the rules, and exponentials is remembering that e to the something, the derivative of that, or e to the x, is just e to the x times some coefficient. And also, the derivative of a constant is just 0. Hope this helps.